sky from cloud to cloud, or hit the ground, right? But if that's the case, how do you explain this? No, you're not going insane. The lightning spidered up from the ground. This is a phenomenon called upward lightning, one that scientists don't fully understand. What they do know is that these upward strikes spring from the tops of tall structures and are triggered by other strikes in their vicinity. According to simulations, these other strikes enhance the ambient electric field around the structures, enough to trigger a lightning strike starting from towers as short as 10 stories. Well, the scientists may not fully understand it, but I know that I'm moving to a ground floor apartment pronto. Freezeway. Lake Michigan, one of North America's 5 Great Lakes. With a mammoth 3,200 miles of shoreline, this lake is home to around 100 lighthouses. And that might seem like a lot, but the weather here fluctuates so much that every last one of them is essential. You see, while the Midwest can receive heat waves that stretch into triple digits, it can also experience Arctic fronts in the winter, with temperatures well below zero and winds exceeding 45 miles per hour. This can drive waves on the lake to crash more than 20 feet over buoys, markers, and lighthouses. But as cold as that looks, it's nothing compared to what the blistery freezing fronts, often more than 20 degrees below zero, leave behind. The freezing water that was crashing against these structures is frozen solid on them and on their piers, leaving them coated in incredible swaths of ice. Some years, the coating the lighthouses receives isn't much, but on others, it has to be seen to be believed. It was so thick in 2019, for example, professional climbers were able to film themselves hacking their way up the side of them like they were mountains. They look like castles plucked from another world. Wait, hold up. Isn't this where Elsa from Frozen lives? Great. Now I'm gonna have Let It Go stuck in my head for the rest of the week. Tsunami ice. Beachfront properties can boast incredible views all year round, whether it's in summer when the waves are crashing or in winter when it's all iced over. Except when the winds pick up in the winter, and all of a sudden hundreds of tons of mammoth-sized ice blocks begin crawling out of the water and inching towards your home. Despite what it looks like, the ice doesn't actually have a mind of its own. This is what's known as an ice shove, though it's sometimes referred to as an ice tsunami because of how big the ice can be and how fast it can roll in, like it did on the Kuskokwim River in Alaska back in 2020.
Whoa! Yep, time to move. Let's roll.
Get on.
What?
Get on.
I'm on. Woo!
Ice shoves occur when strong winds or currents running underneath force the ice from the water's surface to shatter and pile up on the land. And while it might seem tempting to get close, be careful. In stormy conditions, there's no telling just how fast it might come rolling in, as the guy filming this ice shove on Lake Erie discovered.
Oh my God, I can't believe I actually got it.
These massive walls of ice can be so powerful, they routinely uproot trees, break down doors, and even demolish entire homes. Whoa, not cool. Wicked waves. If you've been subscribed to this channel for a while, you might remember my video from several years ago that took a dive into some of the biggest waves ever recorded. If you're afraid of the ocean, like me, just watching surfers and tankers roll around in 70-foot waves is enough to turn your legs to jelly. But giant waves don't just occur in the middle of the ocean. Back in 2015, Typhoon Chan-Hom terrorized the coast of East China with its 140-mile-per-hour winds whipping up waves at the coastal city of Wenling to a horrifying 5 stories high. These waves surged inland, flooding the coast and forced more than 1.1 million people to evacuate their homes. But this wasn't the last time scary storm waves of this magnitude tried to take on buildings along the coast. Back in 2020, the Mediterranean storm Gloria arrived on the shores of Mallorca with winds of 71 miles per hour. While not as severe as Typhoon Chan-Hom, they were still able to whip up waves more than 27 feet tall. I mean, I do appreciate the relentless optimism of these guys, but if a giant wave literally washed over a 3-story building in front of me, I'd be running away from it, not towards it. Dust storm. Usually when you see dark clouds rolling overhead, you need to grab your umbrella. But what do you do if you look up at the sky and see a gigantic wall of orange clouds like this? I don't think an umbrella is going to cut it here. Here being Diego de Almagro in Chile back in March 2022. This isn't any normal storm. It's a dust storm. Sometimes called a sandstorm, these ominous phenomena arise when strong wind fronts blow loose sand or dirt from a dry surface, like a stretch of land or desert after a drought. This cumulates in dense, wall-like clouds that can measure up to 37 miles high. And while an approaching storm looks terrifying, being inside one is something else.
Amainó un poco, pero recién el viento fue terrible. En 5 minutos bajó todas las nubes con polvo y no sé, desde El Salvador y hoy día aquí estamos.
Light filters through the dust and sand, submerging everything in a haze, which interestingly changes in color depending on the type of dust you're squinting through. Chile's dust storm produced a dystopian orange haze, for example. But in southern Iraq, the iron-rich sand and clay of the landscape gives sandstorms like this one from 2010 an unreal red hue.
Not bad, huh? Barely see across the way, which is probably less than 100 feet. And visibility this way, geez, I don't know, 50. And that way, same thing. You can't even tell what's down there.
With dust this red, it's hard to tell whether this footage was shot on Earth or on Mars. Rail rain. There are a few places you might expect to see a waterfall, like in a rainforest or at a water park. You know where you definitely don't expect to see one though? Getting off the subway in New York City. And yet, this is exactly what happened back in September 2021. There's so much water here, I'm not even sure if this is the NYC subway or one of the rides at Universal Studios. All jokes aside, this catastrophic cascade was the result of Hurricane Ida, which dumped 3 inches of rain on New York in just over an hour. Now, this was a big problem because New York's sewage system is only designed to handle 1.75 inches of rain an hour at best. This caused flash flooding throughout the city. But with that in mind, I'm not sure what I'm more impressed with. The fact that the trains were still running, or that people were willing to leap out of the train and into the waterfall. Wave goodbye. Now, it's not just NYC's subway that gets battered by unexpected torrents of water. Over in the UK, Devon's Dawlish line, which is built right along its southern coast, is usually a peaceful train ride that allows passengers to admire the serene seas off the Devonshire coast. That is, until the winter storms arrive. Back in 2014, for example, 70-mile-per-hour storm winds whipped up some 30-foot waves and battered the trains that were still running along the line. These were some particularly powerful waves, one that ended up almost completely destroying a short stretch of shoreline railway. More than £35 million was needed to repair the line, along with a further £80 million to repair the seawall protecting it. But that still wasn't enough. In 2020, a huge storm wave struck one of the trains with so much force, it smashed the windows and injured several passengers on board. Today, storms still continue to threaten the line, like Storm Bara did back in 2021, raising massive waves that the new and improved seawall simply couldn't stop. Yikes. Looks like those improvement plans might have been derailed. Stunning supercells. Now, there are showers, there are storms, and then there are supercells. Wide, anvil-shaped systems of clouds that thrive on 2 tilted air streams, one of upward-moving warm air and another of downward-moving cold air. The humid air rises, condenses, and then falls back down as cool air, forming these supermassive, turbulent storm clouds that can reach 20 miles in diameter and are up to 75,000 feet tall. But as imposing as they look, they become even more menacing when the particles in their clouds collide, building up a static charge, forming an endless supply of lightning. Not sure whether I should be afraid or in awe. Probably both, right? Well, when the rotating updraft feeding this formation really gets up to speed, forming what scientists call a mesocyclone, that's when they can start spawning something a little more terrifying at the ground level. Tearing tornadoes. Tornadoes are pretty terrifying at the best of times. These narrow, violently rotating columns of air generally occur when warm, humid air collides with cold, dry air. As the cold air is pushed up, the warm air begins to rotate, producing an updraft which eventually rotates sharply if winds in the area vary in direction or speed. This produces a huge column of warm, moist, rotating air that is then fed by the cold air coming down from the mesocyclone above. Depending on its size and strength, This funnel system can whip around at speeds exceeding 200 miles per hour, ripping up anything and everything in their path. Imagine the horror, then, that Mary Fan felt back in 2021 as she was driving along when, all of a sudden, a fast-moving tornado tore across Interstate 10 in Texas less than 100 feet from her car. Whoa, was there some lightning in those as well? Well, thankfully, no. It was just the force of the wind snapping the power lines, causing a couple of flaring blue electrical surges. Whew, tornadoes are already terrifying enough on their own, thank you very much. Waterspout scramble. Now, tornadoes don't just form over land, they can form over water too. Although when they do, the weather nerds prefer if you call them waterspouts. However, many that form are much weaker than their land counterparts, meaning that while they look like they're sucking up water from the ocean, they're just fast, rotating columns of air ripping through the waves. The average waterspout is 165 feet in diameter, with winds around 50 miles per hour. Much, much less than those previously mentioned 200-mile-per-hour tornadoes. They almost don't sound that bad. That is, until they reach land. Like this one in the coastal town of Cefalù, Sicily did back in 2020. Chairs, debris, even some trees were flung into the air. A few fish were reportedly dragged from the sea and dumped on land as well. Luckily, this one only lasted a few seconds before the warm stream of air feeding the rotating updraft of the waterspout was disrupted as it reached land, where it eventually collapsed. Super scary, but surprisingly delicate. A bit like my ex-wife. While seeing one up close, but not too close, is pretty mesmerizing, imagine seeing 4 or even 5 all at once, like the onlookers in Laguna de Bay in the Philippines did back in 2020. I mean, we know they're terrifying, but at this distance, and with that sunset behind them, in my opinion, they just look majestic. Now, there are actually 2 types of waterspouts, tornadic and fair weather. Tornadic waterspouts are simply tornadoes that form over the water. They typically occur with thunderstorms, forming from an abundance of warm, moist air and an unstable atmosphere. They develop downward and appear initially as funnel clouds, like this one here. Fair weather waterspouts, on the other hand, form during relatively calm weather. They tend to form along the long, flat bases of developing storm clouds, where air begins to circulate along the surface of the water and develop upwards, much like the one that terrorized Sicily. They typically occur during light wind conditions, and because of this, they don't move much. Even so, if you're out on the water and start seeing droplets flurrying around in a spiral, make sure you start paddling in the other direction. Fire-nado. Okay, so now we've witnessed how terrifying regular tornadoes and waterspouts can be, but have you ever heard of a fire twister? Sounds like something made up for a film, doesn't it? Well, firefighters tackling a wildfire in Greece learned that these things are real and horrifyingly powerful back in 2021. was close. Like being a firefighter wasn't a tough enough job already. Just like fair-weather waterspouts, fire twisters form from the ground up, but are triggered when the hot and fast-rising air is combined with turbulent wind conditions. This draws the smoke and hot air upwards into a funnel, often dragging a whirl of flame up with it. Luckily, most fire whirls are small, ranging from 33 to 164 feet tall. And while they can reach a scorching 2,000 degrees Fahrenheit, most die out quickly. Most, that is. Some, like this one caught on tape on Kangaroo Island, Australia back in 2020, can get so strong that they're able to move away from the base of the fire. But this isn't a fire whirl's final form. In the cases of larger wildfires or even volcanic eruptions, the sheer amount of hot air and ash rising into the troposphere can create flammagenitus clouds, also known as pyrocumulonimbus clouds. Depending on the wind, these ash clouds can become storm clouds, hosting mesocyclones and creating their own actual tornadoes, also known as fire tornadoes. This happened back in 2018 when California's Carr Fire triggered the creation of pyrocumulonimbus, which eventually gave shape to this horrifying EF3 tornado, with winds in excess of 143 miles per hour. At more than 1,000 feet in diameter, this was one of the largest and deadliest fire tornadoes ever recorded on camera. Oh, I do not envy the crew of that helicopter one bit. Brace for the glacier. Glaciers are huge accumulations of ice, snow, and sediment, which, thanks to gravity, move slowly down the land they build up on. They're a real sight to behold, which is what makes Alaska's Portage Glacier, at roughly 6 miles long and 10 stories tall, such a popular tourist destination. The only problem is that tourists forget glaciers aren't solid. They can melt, crack, and fracture, often without warning. And that's what happened to Jason Rausch Jr. and his family, who were visiting Portage Glacier back in 2020.
Oh. Hey, Sue, get off of there! Get off of there! Get off of the ice! Get off of the ice! Whew. Are you okay, Sue? Oh, oh my God. Whoa.
A block roughly the size of a house, weighing tens of thousands of pounds, crashed into the frozen lake below it. But only the surface of the lake was frozen. So the crash sent a small, albeit heart-stopping, under-ice tidal wave towards Jason and his family. If it had been any bigger, they could have been in real trouble. Thank God Jason was able to keep his cool. Changing directions. Your old geography teacher probably taught you that rivers run in one direction, the way gravity leads them, right? Well, that's not strictly true. Some rivers around the world experience an all-natural phenomenon called a tidal bore, which is where the leading end of a tide from the sea is strong enough to push against the river, temporarily reversing its direction. This occurs in places where the mouth of a river or estuary is wide and flat, and the difference between low tide and high tide is quite large. usually about 20 feet in difference. When those conditions are met, a tidal bore can form, like it often does in Moncton, New Brunswick. While Moncton's bore is steady enough to surf on, others can be so big and violent, like those of the Qiantang River in China, that simply standing too near them poses danger. The surging sight of this 30-foot tidal wave has become so famous that it's earned the name Silver Dragon, and thousands of spectators gather along the banks to see it every year. But thrill seekers still get up close to the tide breakers and bends in the hopes of seeing the tide, which can travel at speeds of up to 25 miles per hour, making huge splashes against the barriers. But hang on, how do spectators know when to gather in the thousands for the largest tidal bores? Well, that comes down to lunar tides. When the moon is closer to the Earth, the huge gravitational pull of it draws the tidewaters in that location up. With the moon providing this constantly, the incoming tide is always at its highest along the Qiantang around mid-August every year. However, weather events can also impact just how big these waves become. In 2013, the winds of Typhoon Trami boosted the bore, meaning the high tide was more than twice its usual height. The wave traveling up the river broke through the flood barriers and surged up the banks, sweeping away spectators and pushing them along walkways. Yikes. I think I'll stick to watching videos of this rather than risk watching it in person. Which of these weather events did you think was the most extreme? And have you ever witnessed any firsthand? Let me know down in the comments below, and thanks for watching.